Welcome students. Today we are going to discuss the third part of second module of Basics of Electrical and Electronics Engineering, that is generation of an alternating EMF. Learning objectives are: after this lecture you will be able to explain the generation of an alternating EMF, derive the equation of an alternating EMF, describe certain terms, that is cycle, period, frequency, amplitude, and instantaneous values of waveforms. In the previous modules, we have seen circuits and network in which the current remains constant, that is a direct current system or DC. But in this module, we are going to deal with AC. AC is nothing but it is an alternating current, is the current which changes periodically both in magnitude and direction. Then what is sinusoidal voltage? A sinusoidal voltage is an oscillating voltage that can be described mathematically through the use of a sine function. AC voltage may be generated by rotating a coil in a magnetic field, that is, coil is rotating, magnetic field is stationary, or by rotating a magnetic field within a stationary coil, that is, magnetic field is rotating but coil is stationary. The basic principle of alternating voltage or current is the principle of electromagnetic induction by Faraday. It says that whenever there is a relative motion between the conductor and the magnetic field, an EMF gets induced in the conductor. How we can generate alternating EMF? Now we are going to discuss a simple loop generator for AC generation. The construction: it consists of a permanent magnet of two poles, a single turn rectangular coil or loop ABCD is kept on the vicinity of the permanent magnet. This coil is made up of same conducting material like copper or aluminum. The coil is made up of two conductors, namely AB and CD. Such two conductors are connected at one end to a coil. The coil is so placed that it can be rotated about its own axis in clockwise or anti-clockwise direction. The two ends of the coil are connected to rings mounted on the shaft called slip rings C1 and C2. In addition to C1 and C2, there are two brushes P and Q are resting on the slip rings. The brushes are stationary and are just making contacts with the slip rings. The slip rings and brush assembly is necessary to collect the current induced in the rotating coil and make it available to the stationary external resistance. So this is the simple loop generator. In this, as I already told you, a permanent magnet of two poles, a single rectangular coil ABCD is kept on the vicinity of magnetic field. The two ends of the coil is connected to two slip rings and two brushes P and Q are resting on each of the slip ring. And slip ring and brush assembly is to collect current induced in the coil and make it available to the stationary external resistance R. Assume that The coil is rotating in anti-clockwise direction. While rotating, the conductors, that is coil sides AB and CD, cut the lines of flux of permanent magnet. Due to Faraday's law of electromagnetic induction, an EMF gets induced in the conductors. The EMF drives a current through resistance R connected across the brush P and Q. The magnitude of induced EMF depends on the position of the coil in the magnetic field. At this instant, that is theta is equal to 0 degree. That is, the plane of coil is perpendicular. This is the plane of the coil is perpendicular to the magnetic field. That is, coil sides AB and CD is parallel to magnetic field. That is, coil sides AB and CD is parallel to the magnetic field. So there is no flux is cutting. That is, there is no flux is cutting. Hence, no EMF will be generated in the conductors AB and CD. So no current will flow through the external resistance R. Again, the coil is rotating in anti-clockwise direction. When the coil is rotated in anti-clockwise direction through some angle theta, then the coil sides AB and CD are cutting the flux. In the previous case, theta is equal to 0 degree. Now, theta is greater than 0 degree. Let it be 30 degree. So, there will be some induced EMF in the conductors AB and CD because some of the fluxes are cut by coil. This EMF will drive a current through the external resistance R. In this instant, theta is equal to 90 degree. As we know, as theta increases, the induced EMF also increases. At theta is equal to 90 degree, the plane of the coil is parallel. See, the plane of the coil is parallel to the magnetic field. So the rate of cutting of flux is at maximum level. So the induced EMF in this position is at its maximum value. So coil side AB, coil side CD, AB, CD. So as theta increases from 0 degree to 90 degree, EMF induces in the conductors increases gradually from 0 to maximum value. If we rotate coil further, what will happen? That is, as the coil continues to rotate further from theta is equal to 90 degree to 180 degree, the component of velocity perpendicular to the magnetic field starts decreasing. That is, we will get maximum EMF at theta is equal to 90 degree and 0 EMF at theta is equal to 0 degree. So minimum value to maximum value. Now the EMF gradually decreasing. Then at the instant theta is equal to 180 degree, the coil sides AB and CD are fully parallel to the lines of flux, which is similar to instant 1. Then there is no cutting of flux, so no induced EMF in both the conductors. Hence, current through the external circuit is 0. If we rotate coil further, that is beyond theta is equal to 180 degree, the conductor AB is now cutting the flux lines in one particular direction, reverses the direction of cutting of the flux lines. That is, in 0 degree to 180 degree, the coil side AB is under north pole influence and coil side CD is under south pole influence. But beyond 180 degree, coil side AB is under south pole, but coil side CD under north pole. So the direction of induced EMF in conductor AB is opposite to the direction of induced EMF in it for the rotation of theta is equal to 0 degree to 180 degree. So the direction changes. The direction of current and the direction of induced EMF changes. Similarly, the direction of the induced EMF in conductor CD also reverses. The change in the direction of induced EMF occurs because the direction of rotation of conductors AB and CD reverses with respect to the field as theta varies from 180 degree to 360 degree. Now AB is under south pole, CD is under north pole. This process continues, a coil rotates further. At theta is equal to 270 degree, again the induced EMF achieves its maximum value, but the direction of this EMF in both the conductors is opposite to the previous maximum position, that is theta is equal to 90 degree. From theta is equal to 270 to 360 degree, induced EMF decreases without change in direction, and at theta is equal to 360 degree, coil achieves the starting position, that is theta is equal to 360 degree is nothing but it's the starting position with 0 induced EMF. So as theta varies from 0 degree to 360 degree, the EMF in the conductor AB or CD varies in an alternating manner, that is 0 increasing to achieve maximum in one direction, decreasing to 0, increasing to achieve maximum in other direction, and again decreasing to 0. The instantaneous value of induced EMF in any conductor as it is rotated from theta is equal to 0 degree to 360 degree through one complete revolution can be represented as shown in the below figure. So in this is the theta is equal to 0 degree position. As we already discussed, the EMF is 0. Now the coil is rotating in anticlockwise direction. When theta is equal to 90 degree, we will get maximum value of induced EMF. If we rotate further, then at theta is equal to 180 degree, again the EMF will be 0. If we rotate the coil further, that is beyond 180 degree, the direction reverses. At theta is equal to 270 degree, the exact case of theta is equal to 90 degree, but direction reverses. And then theta is equal to 360 degree, we will get the same position as that of theta is equal to 0 degree. So now we have got an alternating waveform. That is, so instead of resistor R, I am placing a galvanometer. Once more, instead of resistor R, I am placing a galvanometer. So we can see positive deflection as well as negative deflection. How we can write equation of an alternating EMF? A mathematical analysis is there. Let omega is the angular velocity of the coil in radian per second. V is the linear velocity in meter per second. B is the flux density of the magnetic field in Weber per meter square or Tesla. L is the length of the coil side parallel to the axis in meters. Theta is the angle swept by the coil in a time t seconds. R is the radius of the magnetic path in meters. Consider our previous singleton rectangular coil ABCD rotating with a constant angular velocity of omega radian per second in a uniform magnetic field. The axis of rotation is being perpendicular to the magnetic lines of force. This is very important. The axis of rotation is being perpendicular to the magnetic lines of force. Let the time be measured from the instant the coil lies in the plane of reference x o x dash. This is the reference plane. The angle theta swept by the coil in a time t seconds is given by theta is equal to omega t. Let v is the linear velocity, as I already told you, that linear velocity is equal to omega into r. So in this figure, we can see two components of linear velocity, that is v cos theta and v sin theta. But we are considering perpendicular term only, that is v sin theta. So linear velocity of the coil side at right angles to the magnetic field is equal to AR, which is equal to v sin theta. Instead of theta, we can write omega t. So we know that flux cut by conductor is the induced EMF. So flux cut per second is equal to BLV sin theta, as we already studied in first part of the module 2, magnetism. So flux cut per second is equal to BLV sin theta. Instead of theta, we can substitute omega t. So BLV sine theta is equal to BLV sine omega t. Thus, EMF generated in one coil side. We have a rectangular coil ABCD. AB is the one coil side, CD is the another coil side. So the EMF generated in one coil side, let it be AB, at a time t is equal to BLV sine omega t. So the total EMF generated in the entire coil at a time t is equal to 2 times BLV sine omega t. Instead of V, we can substitute omega into R, as we already discussed. But the maximum flux linking the coil, let it be phi, is equal to B into A. That is flux density into area. So what is the area? Area is the, as we already know, area is equal to length into breadth. In this, length, that is length of the coil side, and radius of the path. This is the area. Length of the coil side and radius of the path. It's a rectangular coil with the length. The coil is rotating. Assume that a circular rotation with a radius r. For a single conductor, the radius is r. So the area of the single conductor or coil side is, suppose AB, coil side AB. So length is L and the radius is r. So L into r. But here two conductors, that makes a loop. So 2 times L into R. Thus, EMF generated at time t is written as E, small letter E. E is equal to, instead of B into 2 into LR in equation 1, we can substitute phi. So phi omega sine theta. Let it be equation number 2. The EMF will be maximum when sine omega t is equal to 1. That is, when theta is equal to 90 degree, we will get maximum sine value as 1. So EMF will be maximum when sine omega t is equal to 1 at theta is equal to 90 degree. Hence the maximum value of EMF generated is nothing but, let it be EM is equal to omega phi. Let it be equation number 3. So substitute 3 in 2. That is, we have in equation 2 we have phi omega sine omega t is the EMF generated in coil. So instead of phi omega, you can substitute EM. So the instantaneous value of EMF generated at any instant t is equal to, small letter e, is equal to EM sine omega t. Let it be equation number 4. Similarly, the expression for induced alternating current is given by I is equal to, small letter I is equal to Im sine omega t, equation 5. If F is the frequency of rotation of the coil, that is number of cycles passed through per second, then omega is equal to 2 pi F. So substitute omega in equation 4 and 5. We will get E is equal to Em sine 2 pi F t. Similarly, I is equal to Im 2 pi F t. So if the values, EMF values as the given in equation 4 from instant to instant are plotted along y-axis and the time along x-axis, then we can plot waveform. EMF and time. EMF on y-axis, time on x-axis. So what is cycle certain times? So this is the sine waveform. Cycle is nothing but one complete set of positive and negative values in an alternating quantity. Positive and negative. So this is one cycle. What is period or periodic time? So time taken for one cycle, time taken to complete one cycle is time. So this is time. So this is total time t. So t is equal to 1 by f. This is frequency. Frequency is nothing but the number of cycles completed in 1 second. That is number of cycles completed in 1 second. That is cycles per second or hertz. We can express frequency in cycles per second or in hertz. Amplitude. This is the magnitude of the maximum positive or negative values of an alternating quantity. Sometimes it is known as peak value or maximum value. Instantaneous value. The value of voltage or current at a particular instant is known as instantaneous values. So this is all about generation of alternating EMF and equation and certain parameters. This is the basics or fundamentals of AC. In this lecture, you have learned the generation of an alternating EMF. This is by means of a simple loop generator. We have drawn an alternating waveform with different angles. Theta is equal to 0 degree, then 90 degree, 180 degree, 270 degree and 360 degree. So we will get an alternating waveform. Then equation of an alternating EMF. So finally we will get E is equal to Em sine omega t and alternating current I is equal to Im sine omega t. And the concept: cycle, period, frequency, amplitude and instantaneous values. Thank you.